Hey everybody, Mr. Mills here. Today we're going to talk about how to graph quadratic functions that are in standard form. So I'm just going to go ahead and jump right into it. So a quadratic function usually looks something like this. It's ax squared plus bx plus c. Now this quadratic function is in standard form right now. It's in general form because I just have three parameters, a, b, and c. Think of a, b, and c as just regular numbers. So you can think of this as like, I don't know, like 7x squared minus 4x plus 3, something like that. Like a, b, and c are just numbers. We don't exactly know what those numbers are, so we just say a, b, and c for right now. Oops. Okay. So this ax squared plus bx plus c, that is a quadratic in its general form with three parameters. Ax squared, bx, and c all represent something different. Ax squared here is called the quadratic term. It's the quadratic term because it's the term with the x squared. So that x squared is what makes the function a quadratic. The bx is called the linear term. And then c over here by itself is called the constant term. I just say constant. Okay, so we have ax squared plus bx plus c, and it's really this ax squared that makes it the quadratic. So the other day we graphed one of these, and I told you that in a couple days I'd show you how to go a little bit more in depth, and so that's what I'm going to do today. Okay, so what's going to happen is we're going to graph it by making an xy table. The only thing about the xy table is you have to be careful about what numbers you pick for the x values. And to do that, what I'm going to do to pick my middle point here, what I'm going to do is I'm going to take whatever this linear term is, the b, and I'm going to have my middle value right here. That middle value is going to be x equals the opposite of b. Okay, so whatever b is, you're gonna essentially make it negative, or if it's already negative, you're gonna make it positive. And then you're gonna divide that by 2 times whatever a is. So x equals negative b divided by 2a, and that is going to be our middle number right here. Okay, now usually that number will work out really well and be an integer. Sometimes we might get a decimal, and that's okay. But from here, we'll go, 2 numbers up and 2 numbers down, just like we normally do, and we can find our y values and actually plot those points to see our quadratic. Okay, so this x equals negative b over 2a. That is a formula that we're going to need in order to graph these quadratics nicely every time. So let's go ahead and jump into an example down here. I'm going to graph this quadratic. F of x is 2x squared minus 4x minus 6. I'm going to graph this guy, and then I'm going to point out a few key points on the graph, a few key details about it. Okay, so let's just go ahead and dive right in. Let's make our XY table. I'll get a nice pretty color. That's not it. Well, apparently I'm all set. My files are synced. That's good. Okay, not exactly sure what's happening. Sorry about that. Let's go ahead and make an XY table. Okay. And like I said, for this middle value, the middle value is going to be negative b over 2a. Okay. And so, remember b is negative 4, right? So negative b over 2a. Well, b is negative 4, so that's, the opposite of b would be actually positive 4, right? Because we have two negatives there. And then we're dividing that by 2 times a, and a is this number, the 2, the number that's with the x squared. 2 times 2. And when I simplify this, I get 4 divided by 2 times 2 is 4. And then, of course, 4 divided by 4 is 1. And so that, number 1 right there, that is going to be my middle value right here in my XY table. Okay. So from here, I can go a couple numbers above that. I'll go to 0 and -1. And then, I'll go a couple numbers below that as well. I'll go 2 and 3. Okay. And I can actually take these numbers and I can sub them in. So let's see here. I'll start with 1 right here in the middle. I'm going to take 1 and I'm going to sub it into my function in replace of x. So this would be 2 times 1 squared minus 4 times 1 minus 6. And when I simplify, let's see, 1 squared is 1, times 2 is 2, minus 4 times 1 is 4, and then minus 6. And 2 minus 4 minus 6 is -8. Okay? And so I can actually graph that point over here, 1 comma -8. So maybe I do that in another color. 1, 1, 2, 3, 5, 6, 7, 8. 1, -8, about right there. All right. I can do that for a few more points here. So maybe I'll go up to 0. That's a nice number. So we'll go 2 times 0 squared minus 4 times 0 minus 6. So remember, I'm just replacing the x's with 0, with my value. And then I can reduce. 0 squared is 0, times 2 is 0, minus 4 times 0 is, again, 0, minus 6. So 0 minus 0 minus 6 is -6. And then real quick, I'll do x is 2. Okay, so that would be 2 times 2 squared minus 4 times 2 minus 6. When I reduce, 2 squared is 4, and 4 times 2 is 8. And then minus 4 times 2 is 8 again, and minus 6. And I'll reduce that. 8 minus 8 is 0. Minus 6 is -6. So that's 2 nice points there I can go ahead and graph. So I can graph 0, -6, just down here. And then I can also graph 2, -6. So right about here. Okay. So hopefully we see that pattern that these two values are the same. Okay, we'll do our last one. So it would be 2 times -1 squared minus 4 times -1 minus 6. When I reduce, -1 squared is +1. Be careful with those negatives. And then +1 times 2 is +2. And then -4 times -1 right here is +4. And then minus 6. 2 plus 4 is 6. Minus 6 is 0. So that worked out really well for us. Go ahead and take a guess what we're going to get for this last value here. I think it's going to be 0 again. So let's see, we sub in 3. Let's see, 3 squared is 9. 9 times 2 is 18. Minus 4 times 3 is 12. And minus 6. So 18 minus 12 is 6. And 6 minus 6 is 0. Very good. Okay. So I can go ahead and graph those 2 points. So this point up here was -1, 0, right there. And then this point down here is 3, 0. 1, 2, 3, right about there. And we got 5 points. I'd say that's pretty good. I can go ahead and draw my parabola. So that should be a U shape. Do it as best as I can. Yeah, pretty good. Very good. So that is the graph of our quadratic. I told you that we'll go a little bit more in depth here and we can spot some details about the quadratic. So let's see here. Um, so this quadratic in particular, you can see that both of the arrows go up. And so what that means is with this quadratic has a minimum at whatever this lowest value down here is. So on our quadratic, our two arrows go up towards positive infinity forever, which means that this bottom point, this is our vertex, right? The vertex is like the point of the parabola or whatever the shape is. So in this particular case, our vertex right here at the very bottom, this is a minimum of the graph, meaning the graph never goes below this point. So what that means is we have a minimum at this value, and right now at this value, this is the value of y equals, what is that? -8, right? 1, 2, 3, 4, 5, 6, 7, 8, right? So at y equals -8, we actually have a minimum. So I can say that we have a minimum at y equals -8. Okay. What else can I say about this graph? I can also say that our vertex, remember I just said that the vertex is like the top or the absolute bottom of the graph, like it is here. And so here our vertex it's actually this middle point as well. It's this guy. So that's the point 1 comma -8. That's our vertex. Okay. And then something else I could also say about this graph, a little throwback to Algebra 1, I could talk about, this point right here where it crosses the y-axis. That's called our y-intercept, if you remember that from Algebra 1. Your y-intercept is wherever the graph crosses the y-axis. Okay. So our y-intercept is right here. And so that is the point 0, comma, -6. And then I also have some x-intercepts I could talk about. Remember, x-intercepts, or wherever the graph crosses the x-axis, so these two guys right up here, these are both x-intercepts, and these are actually going to be pretty important for us in the future, so I really want to point these out. Those are both x-intercepts. And so our x-intercepts, we have the point -1, comma 0. And we also have the point 3, comma 0. Very good. Okay. I could even go a little bit further, and I could talk about our domain and, of course, our range. These are things we've done a few times in the past. So domain, remember that is left to right, how far left the graph goes and how far right it goes. So for domain, we have arrows. This arrow on the left side here is actually going up and towards the left forever. And this arrow on the right side is going up and to the right forever. So our domain is actually from -infinity to infinity. And our range, remember, is down and up. And the lowest point on this graph is way down here at -8 with a bracket. And the arrows take me up to infinity. And we just talked about a lot of details with our quadratic function.